Hello students, welcome to Maths class. In chapter 8 Quadrilaterals, today's topic is Converse of midpoint theorem. In a previous class, we proved midpoint theorem and solved some problems related to it. Today, we are going to prove converse of midpoint theorem and solve problems based on it. So before we go for this, let's recall midpoint theorem. Midpoint theorem statement: the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of it. So if you consider triangle ABC, where D and E are the midpoints of sides AB and AC respectively, then DE is parallel to BC and DE is equals to half of BC. Now let's prove converse of midpoint theorem. Statement: the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Given in triangle ABC, D is the midpoint of AB and DE is parallel to BC. To prove E is the midpoint of AC, construction through C, draw CF parallel to AB intersecting DE produced at F. Proof: in triangle AED and triangle CEF, angle DAE is equals to angle FCE. Since AD is parallel to CF and AC is the transversal, alternate angles are equal. Again, angle ADE is equals to angle CFE. AB parallel to CF and DF is the transversal, alternate angles are equal. Now BD is equals to CF. Opposite sides of a parallelogram are equal, but AD is equals to BD. D is the midpoint of AB. This implies AD is equals to CF. Since BD is equals to CF and AD is equals to BD, AD is equals to CF. Therefore, triangle AED is congruent to triangle CEF by ASA congruence rule. This implies AE is equals to CE by CPCT. Thus, E is the midpoint of AC. Hence proved. So the line segment drawn through the midpoint of one side of a triangle parallel to another side bisects the third side is proved. Now let's solve some problems based on converse of midpoint theorem. For first, example 8 problem. L, M and N are three parallel lines intersected by a transversal P and Q such that L, M and N cut off equal intercepts AB and BC on P. Show that L, M and N cut off equal intercepts DE and EF on Q also. Solution: given L is parallel to M and M is parallel to N and P and Q are the transversal intersecting L, M and N such that AB is equals to BC. To show DE is equals to EF. Construction: join AF intersecting M at G. Solution: in triangle ACF, BG is parallel to CF since M is parallel to N and B is the midpoint of AC since AB is equals to BC. Therefore, G is the midpoint of AF by converse of midpoint theorem. Again, in triangle AFD, AD is parallel to GE since L is parallel to M and G is the midpoint of AF proved. Therefore, E is the midpoint of FD by converse of midpoint theorem. This implies DE is equals to EF. So we showed that L, M and N cut off equal intercepts DE and EF on Q also. Now let's solve exercise 8.2 problems based on this theorem. Now let's solve problems in exercise 8.2 which are based on this theorem. Problem 4. ABCD is a trapezium in which AB is parallel to CD, BD is a diagonal, and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. Show that F is the midpoint of BC. This is the figure given to us. The solution given ABCD is a trapezium in which AB is parallel to CD. BD is the diagonal, E is the midpoint of AD, and EF is parallel to AB. To show F is the midpoint of BC. Solution: let BD intersect EF at G in triangle ADB. E is the midpoint of AD and EJ is parallel to AB since EF is parallel to AB. Therefore, G is the midpoint of BD by converse of midpoint theorem. Now, AB is parallel to BC and EF is parallel to AB. This implies EF is parallel to DC. So, in triangle CBD, C is the midpoint of BD and CF is parallel to DC since EF is parallel to DC. Therefore, F is the midpoint of BC by converse of midpoint theorem. Hence solved. Therefore, F is the midpoint of BC by converse of midpoint theorem. Hence solved. Now moving on to next problem. Problem 5. In a parallelogram ABCD, E and F are the midpoints of sides AB and CD respectively. Show that line segments AF and EC trisect the diagonal BD. Bisect is to divide a line into two equal parts. Trisect means dividing it into three equal parts. We all know bisect is dividing into two equal parts. Trisect is dividing into three equal parts. The solution given ABCD is a parallelogram. E and F are the midpoints of sides AB and CD respectively. To show line segments AF and EC trisect the diagonal BD, that is DP is equals to PQ is equals to QB. Solution: in parallelogram ABCD, AB is equals to CD, opposite sides are equal. So, half of AB is equals to half of CD. Since E and F are the midpoints of equal sides AB and CD respectively. This implies AE is equals to CF. Let's take it as equation 1. Also, AB is parallel to CD. Opposite sides are parallel in a parallelogram. Therefore, AE is parallel to CF. Let's take it as equation 2. Now, from equation 1 and 2, we have AE is equals to CF and AE is parallel to CF. So, AECF is a parallelogram since a pair of opposite sides is parallel and equal. This implies AF is parallel to EC. In triangle ABP, E is the midpoint of AB and AP is parallel to EQ. Since AF is parallel to EC, therefore Q is the midpoint of BP by converse of midpoint theorem. This implies PQ is equals to PQ. Let's take it as equation 3. Now in triangle CDQ, F is the midpoint of CD and FP is parallel to CQ since AF is parallel to EC. Therefore, P is the midpoint of DQ by converse of midpoint theorem. This implies dP is equals to PQ. Let's take it as equation 4. From equation 3 and 4, dP is equals to PQ and PQ is in turn equal to BQ. So dP is equals to PQ is equals to QB. This implies line segments AF and EC trisect the diagonal BD. Now let's solve another problem. Problem 7. ABC is a triangle right angled at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Show that D is the midpoint of AC, MD is perpendicular to AC, and CM is equals to MA is equals to half of AB. So for solution, given triangle ABC is a right angled triangle, angle C is equals to 90 degree, M is the midpoint of side AB, and DM is parallel to CB. To show D is the midpoint of AC, DM is perpendicular to AC, and CM is equals to MA, which is equals to half of AB. Solution: in triangle ABC, M is the midpoint of AB and DM is parallel to CB. Therefore, D is the midpoint of side AC by converse of midpoint theorem. Again, DM is parallel to CB and AC is the transversal. This implies angle ADM is equals to angle BCM, which is equals to 90 degree corresponding angles. Now, DM is parallel to CB and AC is the transversal. This implies angle ADM is equals to angle BCB, which is equals to 90 degree. Corresponding angles are equal. Therefore, DM is perpendicular to AC. Now to show CM is equals to MA, which is equals to half of AB, we need to join MC. Now in triangle ADM and triangle CDM, DM is equals to DM common, AD is equals to CD, D is the midpoint of AC, and angle ADM is equals to angle CDM, which is equals to 90 degree, since MD is perpendicular to AC. Therefore, triangle ADM is congruent to triangle CDM by SAS congruence rule. This implies AM is equals to CM by CP/CT, but AM is half of AB since M is the midpoint of AB. Therefore, AM is equals to CM, which is equals to half of AB. Now moving on to next problem. Problem 8. In the given figure, AD and BE are the medians of triangle ABC and BE is parallel to DF. Prove that CF is equals to 1/4 of AC. Solution: given AD and BE are the medians of triangle ABC, that means B and E are the midpoints of side BC and AC, and BE is parallel to DF. To prove CF is 1/4 of AC. Proof: in triangle BEC, B is the midpoint of BC since AD is the median of triangle ABC and DF is parallel to BE given. Therefore, F is the midpoint of EC by converse of midpoint theorem. This implies EF is equals to CF, that is, CF is half of CE. Let's take it as equation 1. Now, E is the midpoint of AC. Since BE is the median of triangle ABC, this implies AE is equals to CE. Therefore, CE is half of AC. Let's take it as equation 2. So substituting equation 2 in 1, we get CF is equals to half into half of AC. Therefore, CF is equals to 1 into 1 is 1, 2 into 2 is 4. So 1 by 4 into AC. So that is CF is equals to 1 by 4 into AC. Hence solved. Now let's solve one more problem. Problem 9. In the given figure, ABCD is a parallelogram and E is the midpoint of side BC. E and AB produce meet at F. Prove that AF is equals to twice AB. Solution. Given ABCD is a parallelogram, E is the midpoint of side BC and DE and AB produced meet at F. To prove AF is twice AB. Proof in triangle DCE and triangle FBE, CE is equals to BE. E is the midpoint of BC. Angle DCE is equals to angle FBE. DC parallel to AF and BC is the transversal. Alternate angles are equal and angle DEC is equals to angle FEB. Vertically opposite angles are equal. Therefore, triangle DCE is congruent to triangle FBE by ASA congruence rule. This implies DE is equals to FE by CP CT. Therefore, E is the midpoint of DF. Now, in triangle ADF, E is the midpoint of DF. Proved. And EB is parallel to AD. Since BC is parallel to AD, therefore, B is the midpoint of AF by converse of midpoint theorem. This implies AB is equals to BF. Therefore, AF is twice AB. Today, we proved converse of midpoint theorem and solved some problems related to it. Here we complete the chapter Quadrilaterals. In this chapter, we learnt about quadrilaterals, elements of quadrilaterals, types of quadrilaterals and their properties. We proved properties of parallelogram and solved some problems related to it. We also solved midpoint theorem and converse of midpoint theorem and solved some problems related to it. That's all for now. See you in the next class, students. Thank you.